Hello, this is Mr. Collier, and today we're looking at rates of change using calculus. So when we find the derivative, it has a meaning in some real-life context, and we're going to use that to solve some word problems. When you get the derivative, what you're getting is the rate of change of y with respect to x. Okay, when the derivative is equal to the slope of the tangent, which equals the rate of change. For example, if we have a distance versus time graph, and you get the slope of, say, a linear graph, that is going to be equal to the rate of change of distance versus time, which is the speed or velocity, right? So if we get ds by dt, where s is the distance and t is the time, that actually represents the velocity. Okay, this could be used for any type of situation, like for example, volume versus time or something like that. You'll always get the derivative equals the rate of change of whatever this variable is compared to whatever this variable is. So if we look at this, we have dv by dt. What does that represent here? So we have the volume of water in a container is given by the formula, this formula, where t is the time measured in seconds. So when we get dv by dt, what we're getting is the rate of change. The rate of change of volume. Okay? So how fast is the water entering or exiting the tank or whatever. Okay, this is like the speed of the flow of the water in the tank. What happens, or what units are used for dv by dt? So if it's rate of change of volume per time, then what we're getting is the units are going to be cubic meters per seconds. Okay, so when we get the derivative, we're getting how many? We're getting the rate of change of volume per time. Find the value of dv by dt when t equals 3. So we're going to have to find the derivative first, and just let me do that down here. So we'll have dv by dt is the rate of change of the volume of the tank, and that's going to be 2 minus 2t. Alright, so when t equals 3, which is basically after 3 seconds, we'll have dv by dt equals 2 minus 2 times 3, which is 2 minus 6, which equals negative 4. Okay, so that means that water is flowing out of the tank at negative 4 meters per second, which you might see like this sometimes as well. Negative 4 meters times seconds to the power negative 1, which is the same thing. Okay, and I guess that's basically, I'll just answer part D. That means the water is flowing out of the tank at a rate of 4, sorry, this would be 4 cubic centimeters per second. Okay, next example. So you can also do this kind of thing for a company's profit. So the profit of a company is given by this function. We're going to find P0 and P6 and then interpret the results. Okay. So P0, that means that so this is profit. This is a function of profit given a mass x of copper that is mined. So P0 is 2.3 times 0 minus 0.05 times 0 squared minus 12, which gives you negative 12. Okay, and notice in the question it says in millions of dollars. So this is negative $12 million. So to interpret that, it means that with 0, is this grams or kilograms? It doesn't say exactly. But with 0, well, I guess 0 grams, 0 kilograms is the same thing. 0 kilograms of actually it's tons, sorry. With 0 tons of copper, the company will lose 12 million. Okay, or maybe you could think of that as the startup costs. At the beginning, you have in mind any copper, so maybe the startup cost is 12 million. P6. Okay, so put that in. We'll get 2.3 times 6 minus 0.05 times 6 squared minus 12. I'm not going to do that on the calculator. 2.3 times 6 minus 0.05 times 6 squared minus 12. Oh, and we get 0. Alright, so now you can think of this as, well, you start off with a loss of 12 million or starting cost of 12 million. What this means is that if the company mines 6 tons of copper, it will break even, which means no profit, no loss. Okay, next, part B. I'm going to find dp by dx and interpret what it means. So dp by dx, I need to see the original function here, okay, is 2.3 minus 0.1x, okay? And this represents the rate of change of profit with respect to the x value is amount of copper, right? Amount of copper. Okay. So part C, find dp by dx when x equals 20 and when x equals 25. Okay, so if we do x equals 20, we're going to have 2.3 minus 0.1 times 20, which equals 2.3 minus 2, which equals 0.3. Do the same thing for x equals 25. 2.3 minus 0.1 times 25, which equals 2.3 minus 2.5, which equals negative 0.2. Okay, so what this shows us is actually that if you mine 20 tons of copper, your profit is increasing. But if you get to 25 tons of copper, your profit is actually starting to decrease. Okay, so that's useful information for a company. Find the value for which dp by dx equals 0. Okay, so if for part D, I let the derivative equal to 0. Oops. And then solve for x. So I'm going to minus 2.3 from both sides, and I get negative 2.3 equals negative 0.1x, divide by negative 0.1. You could do that on your calculator if you like. You will get positive 23. Okay. So we saw here that the profit is increasing and it's decreasing, but the profit is staying the same if you're mining 23 tons of copper. Okay. All right. Determine P for this value of x and interpret this value. So this is our original profit function, and we're going to have to find the P value now at when x equals 23. So we're going to substitute this into the equation and see what we get. 23 squared and minus 12. So P of 23, which means the profit after 23 tons of copper is mined, is, so let's just type that on the calculator. So we get $14.45. So remember that means $14.45 million. Okay. $14.45 million. So I'm going to graph the function now and show you what it looks like if you were to put equation into with y equals here on the calculator and graph and change the window a bit. You see it's a parabola, and if you look at this point up here, and I can even get it by second function trace, so I can get the maximum value. And so I'll just go, I'll press enter and then go to the right here. So if I get this maximum value, it's the same as the value we just calculated. And you can see from the graph that this is the maximum profit right here. Okay, so we saw before that if the amount of copper goes up to 25 tons, you're actually starting to lose some of your profit. And when the amount of copper is 20 tons, you're over here, so your profit is still at the maximum. The maximum profit occurs when you mine 23 tons. So that's how you would interpret that problem.